Hi, today we'll speak about Monte Carlo simulations in Python, here you can see that I'm using Jupyter Notebook as a notebook style coding. And what is actually Monte Carlo? It's methods, usually experiments, that rely on a random sampling to obtain numerical results. Usually it's used with certain type of distribution, for example normal distribution, but today we will use our observation, our historical values of a particular stock. So let's start by importing our packages. I'm going to import pandas first, then let's import NumPy. And we will need the package which is called Yahoo Finance or Y Finance to get the stock data. Good. And last but not least, we will need to import datetime, and in particular I will need time delta. Good. So today we will track Microsoft for the last 5 years. I'm going to go for Microsoft YF.ticker, and here we need to type the ticker, which is MSFT. Then we're going with the history, which is MSFT.history. The auto completion is not really working. Right, this, and I'm going to go with periods of 5 years. Usually a year is also good, but let's have 5. Then when we look at our data frame, we see that it has some kind of day like time here that we don't really need. So maybe it would be good if we take this out. How to do this? I'm going to use a list comprehension. Is.index like this. And now if you look at our histogram, we have just the data. All right. Next we'll need our returns. So what are we going to do? We're going to get the close price out of this. So I'm going for close dot pct change, waiting for this autocomplete, but it's not popping up, so I'm going to write this manually. So like this. All right, so here I get the values. Now I will need to multiply this by a value in order to get a new price. That's why I'm going to add here 1, and I'm going to put this as a returns multiplier, like this. All right. Now, as we have returns multiplier, we will need a start and end date. So start date would be our last value of the index. So we're going with index with -1. And for the end date, we're going to go with let's say 60 days of simulation. All right. Next up, we also need the last price. So this will be our starting price. And this is, let's say, last price is going to be histogram. And for there, we're taking the close. And the last element. And also the simulation output will take this as the first now it will take the first price, so this is the last price, but however it will multiply it by a random dot choice of the returns multiplier. So basically the randomness in our experiment is that whatever was the percent change before will continue to be in the next 60 days. So it will basically choose from a change that was in the last 5 years as a percentage. Of course, this experiment can be made better, adding more information, adjusting it a bit, but here we're just showing how to do it in a basic way. You can extend it further if you'd like to do it. So the simulation output, this is just the first value of it. So if you want to see it, this is the first value today is 13th of October 2023. So let's say that tomorrow, this is what our experiment is saying that it will be. However, we're not interested in just tomorrow. So we're going to go with the for loop. We're going to for loop. And we're going with the range of 60. Please add this to it. So I will need to add, but I will also need to use the simulation output. So I need to multiply each time by the last element of the output. So I will need -1. And again, similar to the above, I need a random value from our returns multiplier. Like this. Good. So now when I look at the simulation output, I could see some values and some price movement, let's say. It looks a lot like a white noise, which probably is, but it should provide some kind of a good experiment output. All right, so next up we need to perform a data frame. Let's say that I'm going to name it df and this df. So I will directly go with the merge. I will merge histogram. I will merge the historical data with the new data frame, which will be all right. So I'm going to need date here, and the date is going to be pd.date range to generate a date range. The start would be our start date. Let me name this argument. Then the end would be our end date. And the frequency would be day. All right. Then our next value will be, here I need to close the brackets, put a comma, and the next one would be simulation output. Like this, and here we can simply put simulation output list. All right, and then here it would be good if I go with set index to be date. And then I need to provide the other arguments in the merge, which is the left index is going to be true, and the right index is also going to be true, so that they merge on index. And how I need an author so that we keep both values. Author like this. If you don't know the parameters, with Shift Tab in Jupyter Notebook, you'll be able to look at them. Here is also the doc string, so you can double check if your how exists. So I'm using an author, so I use both frames, and it's similar to the SQF author join if you're familiar with that. All right, so now as I have this, I can simply create it and I can look at it. Good. So now I can plot it, and I can go with the close price, and I also just need the sim output. Like this, and then if I go with this plot, it should look something like this. So this is our real values, and here we have some kind of like a prediction of a simulation output, and it looks totally possible. However, there's no real fundamental analysis that backs, or any technical analysis that backs up this maybe forecast. However, you should not treat it as a forecast, because if we run it again, there will be different output. You can of course build a function out of this. I'm just going to show it here for you. So if I have this generate simulation functions, which take a data frame, the number of simulation, ID of simulation, and custom start date. Why? Because we need, if we want some custom start date to start with. So if I create this function, I can generate another simulation. So this simulation would take data frame as an input, the simulation ID, which I'm going to go with 2, and I'm going to need the custom start date. So the start date of this would be 2023, 10, 12. Like this, and you can see that I have another simulation over here. So if I output this as a, by the way, if I run this again, I'm going to have a new values. Now this is no. However, yes, maybe because we have some non-values. Anyway, I can back this up by, for example, df equals, and yeah, I can basically now plot the same as above, but with simulation 2. So you can now see that we have sim output, which is the first one, and then we have our output of the second simulation. And basically this too much is a bit by increasing the price, but this of course don't take this financial advice. It's just simulation and just showcase how to use Monte Carlo logic. All right, that's all. Hope you enjoyed. See you soon.